Hello, everyone. My name is Deng. I'm from Rutgers University. Today, I'm going to present our work on near duplicate text alignment. Let's get started. Textual data is ubiquitous. It takes account for about 18% of all information, and the enormous amount of textual data is generated by our daily used applications, such as Twitter, Reddit, Wikipedia, and news articles. On the other hand, textual data is usually very messy because it contains a lot of typos, abbreviations, synonyms, etc. It is estimated that about 14% of web contents are near duplicates. We're interested in the near duplicate text alignment problem. It takes two long texts and a Jakarta similarity threshold as the input, and it produces all the passenger pairs whose Jakarta similarity is above the threshold. Maybe the most typical application of this problem is plagiarism detection. For example, in academia, reusing a piece of passengers from another paper without quotation is deemed as plagiarism. On the slide, we show two speeches from the two first ladies in the United States, and the highlight part is an example of near duplicate passenger pairs. The challenge of this problem is the high computation cost. This is because there are way too many passengers in a long text. For example, for two academic papers with tens of thousands of words, there are quintillions of passenger pairs in them. We propose a min hash-based method to tackle this problem. In min hash, each word in a passenger is converted to an integer. And the min hash of the passenger is the minimum word hash value in it. And if we do multiple hashes, the ratio of the common min hash between two passengers is an accurate estimator of their Jakarta similarity. However, there are still quadratic number of min hash in a text. We observe that a lot of nearby and overlapping passengers would share the same min hash. For example, on the slide, the four passengers all have the same min hash value, 20. Based on this observation, we propose to define a compact window using three integers, where L and R are the left and the right boundaries of the compact window, and the C is the index of the word with the minimum hash value. Clearly, all the passengers in the compact window containing the sixth word would share the same min hash. To generate a compact window for each position C in the text, we can extend on the two ends as far as possible until we met the first word with a smaller hash value. And in this way, there's one and only one compact window for each position C in the text. Thus, there are just n compact window for text with n words. And we can further prove that each passenger is in one and only one compact window. In this way, the quadratic number of passengers is represented by just a linear number of compact windows. In the paper, we discuss more details, such as how to efficiently generate all the compact windows, how to find the results directly using the compact windows, and how to deal with duplicate words. In the experiment, we used a real-world computation dataset, and we compared with two baselines. The first one, PKYs, can only generate fixed lengths near duplicate passenger pairs. And the second, SEF, short for seeding, extension, and filtering, is the champion method for that computation. It is a heuristic method with more than 10 hyperparameters. And here is the experimental result. We can see PKYs has a very low F1 score because it can only generate fixed length passenger pairs. While our method, ALLIGN, improved the state of art from 0.42 to 0.48. And if we combine our method with the champion method, SEF, we can further boost the recall to 0.51. And in conclusion, we propose the first non-trivial methods for all pair near duplicate text alignment. In the experiment, our method significantly improved the recall of plagiarism detection. Thank you.